Hello students, welcome to my channel Parina Jain Tutorials. So here I am with my next video, that is part 5 of acid, bases and salts. In this video I am going to explain you about pH scale. So let's start. First of all, let's understand what is pH scale. The pH scale is a scale for measuring H plus ion concentration in a solution, that is called pH scale. How this pH scale is helpful? This pH scale is helpful in measuring the strength of acid. We are having two types of acid. One is strong acid and weak acid. Similarly for base, we have strong base and weak base. So how we come to know that which one is strong and which one is weak? That all depends on H plus ion concentration. So this pH scale is helpful in measuring the H plus ion concentration. P here stands for the potence, means power, and H means the H plus ion concentration. Basically the formula of pH is minus log H plus concentration. This N here, which is in power of H plus ion, this is the number. N could be any number from 0 to 14. So this number basically tells us that what is the H plus ion concentration. More this power, more the solution will be having OH minus ions, and the solution will be basic in nature. Less this power means the H plus ion concentration is more, and the solution is acidic in nature, because this N power is from 0 to minus 14. Basically it's 0, then minus 1, then minus 2, then minus 3, like this way. That is why in minus, when this power increases, so H plus ion concentration decreases. That is why the whole value of pH comes out to be in plus, and this will tells us the solution will be acidic or basic in nature. If the value, we are not going to do these formulas, we are not going to consider this formula. We are just bothering here about the pH scale. I'm just explained you this formula so that you come to know that what is the actual use of H plus ion concentration. So pH here, if the pH is 0 to 6, that means the solution will be acidic in nature. If the pH will be 8 to 14, that means the solution will be basic in nature. And if it is 7, that means the solution is neutral in nature. Now how it is related to H plus ion? Let's understand here. If the pH is 0, that means there is more amount of H plus ion and there is no OH minus ion. Hydroxide ion is nil. If the pH is 1, that means H plus ion is this much and a very small amount of OH minus ion is also present. If the pH is 2, that means this much of H plus ion and the OH minus ion is also there. Means in every solution there is H plus and OH minus ions, but if the H plus ion is more than the OH minus ion, then the solution will be acidic in nature. And if the solution will be having more amount of OH minus ion and a less amount of H plus ion, then it will be basic in nature. And if it is having equal amount of H plus ion and equal amount of OH minus ion, that means the solution will be neutral in nature. Means the neutral solution will also contain H plus and OH minus ions both, but these concentrations are equal in nature. That is why the solution is neutral. Now there are so many products available in our house. So how we come to know that what is the pH of those solution? So through this data, through this table, we can find out. For example, in our stomach releases HCl acid for digesting the food. The pH of this HCl is around 1.5. That means it is highly acidic in nature. How we come to know about the strength? For the strength, we could say if we are moving away from this 7, that means these all the solutions from 0, 1, 2, 3, we could say these all solutions are strongly acidic or strong acids. And the solution from 4, 5, 6, these are weak acids. Similarly, it's for base. The more far we go from the 7, the more OH minus ions will increase. That means the solution will become more basic or strongly basic. So the solutions which is having 11, 12, 13, 14, these all pH solutions will be strong base, and the solutions of 8, 9, 10 pH will be weak base. Now the hydrochloric acid, which is having a pH of around 1.5, is strong acid. Then lemon juice is having a pH of around 2. Grapes are having a pH of around 3. Tomatoes are having 4. Bananas are do not give sour taste, but actually it also contains a small amount of acid, very mild acid. That is why it is having a pH 5, and 5 pH means weak acid. Then milk also contains, I explained you that milk contains the lactose sugars which convert into lactic acid. So it also contains mild base, a mild acid. That is why it do not give a sour taste, but actually it is having a small amount of acid. That is why it is having a mild weak acid. Pure water is not having any means equal amount of acid and base. That is why it is neutral in nature. Why it is neutral in nature? Why we are saying that it is having equal amount of acid and base both? Because in pure water the H2O is having H plus ions and OH minus ions. It is made up of H plus and OH minus ions, and these ions are equal in amount. That is why it is neutral in nature. Then baking soda, soap, ammonia, bleach, oven cleaner, these are all basic in nature, which is available in our home. And apart from this, milk of magnesia or the digen which we use in the case of antacid, when we are having acidity, so we use it as an antacid. So that is also that is also basic in nature, a strong base. Now let's understand what is the strength of acids. On the basis of strength, we can classify the acids and bases into strong acids and weak acids. Similarly for base also, strong base and weak base. Strong acids means that the acids completely ionize, they produce large amount of ions. When acid is dissolved in water, it produces large amount of hydronium ion and chloride ions. It ionizes completely, that means 100% or around 90%. It ionized into it means dissociate into ions. Weak acids are those when they are dissolved in water, they also produce ions, but they produce less amount of ions. Most of the compounds remain in the molecular form only. They do not dissociate into ions, they do not split into ions. So the very less amount of molecules are able to split into ions. That is why they are known to be a weak acid. These weak acids are range from 4 to 6, and the strong acids are range from 0 to 3. So these, by the pH scale also we could determine, or by this also we could determine. Another way is, if we put a if by the electrical conductivity also we could find out. For example, we have taken a weak acid like acetic acid, CH3COOH is an acetic acid if we have taken a weak acid, and on the other hand we have taken a strong acid, HCl, in a as a form of solution. Now we have put a bulb to it, so we have found that bulb in the weak acid is glowing dimly, and in the strong acid the bulb is glowing very brightly. So this bright nature of bulb also showing that this is a strong acid and this is a weak acid. If we do not know the solutions that which one is strong acid and which one is weak acid, and if we are not having any pH scale, so how we come to know, how we find out that which one is weak and which one is strong? So by this activity we could find out that which one is strong acid and which one is weak acid. If the bulb is glowing dimly, that means that one is a weak acid, and if the bulb is glowing brightly, that means that one is a strong acid. Now another way of measuring the pH, that is a universal indicator. How we come to know? We have seen the pH scale, we have seen all the colors on the pH scale, we have seen that 0 to 14, the range of this scale tells us about the pH scale. But how we measure this pH scale? So we can measure this pH scale by using the universal indicator. So universal indicator is having a same type of strips which we have seen in the litmus paper. If or we are also having a solution of universal indicator. Why we are calling it as a universal indicator? We have done that, which by changing their color, they tells us about the substance, the given substance, that whether it is acid or a base. So by this indicator we come to know that whether the given substance is acidic or basic in nature. Universal we are using because it tells us about acid, bases, as well as for neutral solution. It tells us about all the solutions. That is why we use the word universal indicator. Now if we add the few drops of this universal indicator to the acid, we see the color change to be red. And if we add a few drops of it to the base, we see the color change to be blue. Okay, on this paper also we the range is given to us by this on the marking also given to us. So by the marking we could check out that on which marking it is coming, that means what is the pH. Otherwise we could remember this rule, Vibgyor you must have remembered. So green stands for neutral solution, and yellow, orange and red, this tells us about acidic. If the solution is yellow, orange or red, then the solution is acidic in nature. And if the solution color comes out to be blue, indigo or violet, then the solution is basic in nature. The deeper the color, the more is the strength of that compound, of that acid or base. For example, if yellow is lighter, we know orange is deeper, and in between orange and red we could also get pink color, and that we are having a range of red color also. So the deepness of the color tells us about the strength of acidity. Similarly, the deepness of the blue color tells us about the strength of basicity. Now look at the activity. In this activity we come to know about how the universal indicator works. We have added the universal indicator to water. We see the color is green now. To this same solution, when we add the acid to it, we see the change in color, that is orange, from yellow to orange. Now we have added a pellet of sodium hydroxide. The sodium hydroxide will dissolve in the solution and will make the solution blue. First of all, it is neutralizing the H plus ions, and whatever the rest of OH minus ions will remain in the solution, that OH minus ions will give the deep blue color to this solution. Now this is another way by which we are finding out the universal indicator. This is a red cabbage we are using. We have added water and now we are mixing in a mixture jar. We are making a thin paste of it. After doing it, we will stain it. So this is our indicator, a universal indicator of red cabbage. Now we add this to the vinegar, water, Sprite, sugar and baking soda, and you could see the change in colors. Now let's learn about what is the importance of pH in our everyday life. So first example is pH of acid rain. If the pH of rain reaches below to 5.6, then it causes the acid rain. the rainwater becomes acidic in nature. What are the causes of this acid rain? The acid rain is caused due to the exhaust released from the factories, from the burning of fuels, or from the vehicles. These exhaust gases are harmful in nature because they are acidic in nature. They contain carbon dioxide, sulfur dioxide, nitrous oxides, which are harmful gases. So these gases, when combined with the rainwater, they makes the rainwater acidic. This acid rain, when reaches to our earth, then it causes harmful effects in many ways. So first harmful effect is it damages the skin of human beings, the animals, the birds, the plants, and also affect our aquatic life. It also affect adversely to monuments and buildings. Then the pH in our digestive system. The pH in our digestive system should also be maintained. This is helpful for our digestion. The hydrochloric acid which is released in our stomach, that is important for the digestion, but if hydrochloric acid is released in excess amount, then it causes pain and irritation, and this is the situation when we feel acidity. In this situation, we should take antacid, which is magnesium hydroxide or milk of magnesia. We also take baking soda or ENO, which also contains base in them. This base neutralizes the acidic nature and relieves us from pain. Then the pH in our mouth should also be maintained. If this pH reaches below to 5.5, then this pH, this acid, corrodes our teeth. The bacteria which is present in our mouth produces acid by degrading the sugar. That is why we should always brush our teeth before going to the bed, and we should not eat sugary or junk food during the night time, because the sugar which is present in the food, that causes decay by the help of bacteria, and it turns into acid, and this acid corrodes our teeth in badly manner. The Pepsi, the Coke is having a pH of 3.4, which is highly acidic in nature, and this acidity is strong enough to dissolve our teeth and bones. So be aware of this Pepsi and Coke. Now the pH of soil is also should be maintained, very important for the healthy growth of plants. If the soil becomes very acidic in nature by the use of fertilizers, then in this situation we should add chalk powder, calcium oxide or calcium hydroxide in the soil. This base will neutralize the acidic nature of the soil, and if the soil will become too basic in nature, then in this situation we could add manure to it to neutralize the basic effect of the soil. There is a self-defense mechanism in plants and animals by a chemical welfare. Honeybees releases methanoic acid, or also known as formic acid, in its sting. So whenever we have a sting of a honeybee, you must have seen that there is a lot of pain and irritation and also swelling in that stung area. And when we rub some baking soda, toothpaste, calamine lotion on that stung area, we get relief from pain and irritation. In the same way, the nettle leaves also releases methanoic acid, or also known as formic acid, through the stinging hairs. So nettle leaves are also having the stinging hairs. By these stinging hairs, they give a cut and give the pain to our skin whenever we cross these nettle leaves from nearby. Then the dog plant is also present near these nettle leaves, and this dog plant is containing base in them. When we rub this dog plant on the cut area, on the stung area, then we get relief from the pain. Now students, there is a time to do the questions from the learned topic, and if you face any problem, you can comment me, and also comment me about how much you are liking my video. This is all for today students. Thank you. Take care. Stay healthy.